welcome to my lecture. Today we are going to solve an interesting problem for Olympiad math. The problem states that solve for positive integer a and b such that 2n minus 1 over a plus 2n over b equal to n plus 1 when n is a natural number. So we have to find integer a and b such that this equation hold. So let's start with this. So it was given that you have to find a and b from this equation. So to simplify, let's multiply both sides with a and b and we will make it free of the fraction. So when you simplify this product, so you will get it 2n minus 1 multiplied b plus 2na equal to n plus 1ab. We'll take it on other side and then we'll get it 2n plus 1ab minus 2na, and this is minus 2n minus 1b is equal 0. Now from there we'll take it 2n plus 1a. From this two term we'll take 2n plus 1a, and then you will get it b minus 2n over 2n plus 1, and here minus 2n minus 1 multiply b. We want a similar kind of the factor like this, b minus 2n over 2n plus 1. So we'll add and subtract some terms. So we'll add related expressions on both sides. So you got it here, plus 2n 2n minus 1 2n plus 1 is equal 2n 2n minus 1 over 2n plus 1. So this we add it on both sides. Now from this you will see that 2n minus 1 2n minus 1 is common. So we take out 2n minus 1 and we will get it this expression. Now b minus 2n over 2n plus 1, b minus 2n over 2n plus. This is a common factor, so we take out, and from there also we take out 2n plus 1 with a, because we want a expression separate for a and b. So we got it now this one. Okay, so further simplify, take this 2n plus 1 on the other side, so you will get it 2n over 2n minus 1 over 2n plus 1 whole. So now this left side is have two factor, left side have two factor. So we want to make this expression on right hand side two factor in such a way so that each factor will be equate with the other factor on the right hand side. Now there are many possibilities for this factor. So we'll try to list it all possible factors for this expression and then compare with these two, and then we'll get the solution. So first let's check the factors of this expression. So 2n 2n minus 1 2n plus 1, very initially it can be separate like this. So if you do this, then we will have, and now we just change the position because we have a factor we can compare with both of these factors, and we'll see that what is the possible solution. Maybe in one case we have the solution, other case we don't have. So now second set is 2 over 2n plus 1, and n here just shift the n on the other side, and then its counterpart is like this. And then third one we have 1 over 2n plus 1 and multiply 2n 2n minus 1 over 2n plus 1. And the last one is like this. So we took this sixth factor and we'll consider one by one all six factor, and we'll get the possible solution, or we'll highlight that what is the difficulties. Now let's start with the first one. So if we take the first one, so we can write it like this. Now we can take any one of them, but to understand clearly, we take the first factor with first factor, second factor with second factor. Reverse one we'll consider separately. So we take the first factor with first factor and second factor with second factor. So that means a minus 2n minus 1 over 2n plus 1 equal to n over 2n minus 1. If you simplify it, you will get it here a equal this 4n minus 1 over 2n plus 1 and b also equal 4n minus 1 over 2n plus 1. Now in this case, this a and b will be integer only when n equal 1. Other cases it's not integer. So therefore a and b are integer and equal 1 only when n is equal to 1. So this solution is valid or when n is equal 1. And the values for a and b will be 1. Now take the second case, means here we take the separate position of this factor than the previous one. And then we compare it again, first one with first, second one with second. And if you solve it, you will get it here 4n minus 2 over 2n plus 1, b equal 4n over 2n plus 1. In either cases, the a and b are not integer for any a and any n. Okay, so let's move to the second set. In second set, we have this set. A is the right hand side can be written as in this two factor and take the first one with first, second one with second, and then we compare it. If you get it here, if you solve it, simplify it, this plus this, you will get it 2n plus 1 over 2n plus 1 a equal 1. Same way, you will get b is equal n. So a equal 1 and b equal n are integer. So therefore, we have this is one of the solution of this equation. A is equal 1 and b equal n. Now come to the reverse of this set. So if you reverse the position here, then if you compare it first with first, second with second, then you will get a equal to n minus 1, n plus 1 over 2n plus 1, b equal to n plus 2 over 2n plus 1. In either cases, they are not integer. So therefore, this is not accepted. Now come to the third set. So third set can be written is like this. And then again, in the similar process, take the first factor with first, second factor with second, and then you will get a equal to n over 2n plus 1, which is always a non-integer, and 4n square over 2n plus 1, it is also a non-integer. So therefore, we don't get the integer. So we don't have the solution here. Now the last one is like this, and here you will get it this and this. Now if you compare it, so it is a equal to n plus 1 over 2n minus 1 over 2n plus 1. So this will gives you 2n minus, and b is equal 1. So therefore we get the roots a equal to n minus 1 and b equal 1. These are integer. So therefore, this is our solution. So finally, we have three cases: n equal 1, we have a equal 1, b equal 1, and for any n, we will have a equal to n minus 1, b equal 1, and for any n, a equal 1, b equal n. So these are the solution. And you'll see that the first case is also coming in both cases when n equal 1 if you substitute. In this case also a equal 1, b equal 1. In this case also a equal 1, b equal. So let's have some example on this. The question is like this: 3 over a plus 4 over b equal 5. So if you compare with the previous question, so it n equal 2. And then the solution is a equal 1 and 2, and a equal 3, b equal 1. Now let's have 5 over a, 6 over b equals 7. So in this case, n is equal 3. So the solution are a equal 1, b equal 3, and a equal 5, b equal 1. Let's have another example. 15 over a plus 16 over b is equal 17. So in this case, n is equal 8. So the roots are a equal 1, b equal 8, and a equal 15, b equal 1. That's all.